to run RIP version 2 on router R2. I think what we might do at this point is introduce a static route back into router R1. Remember how we did that earlier? Let's go into global configuration mode and let's say IP route, and let's point specifically over to 10.1.2.0. We can give subnet information now, 255.255.255.0, and we're going to specify a next hop IP address of 192.168.1.2. Now let's take a look at our IP routing table. Show IP route. Show IP route now gives us specific route information for the 10.1.2.0 network. So let's once again try this. Let's try to ping 10.1.2.2. Success. Beautiful. Let's try to ping 10.1.1.1. That is successful as well. Excellent, excellent. Let's go over to router R2. Over on router R2, if we do a show IP route, what does it see? It still knows about these other networks via RIP version 1. Remember, router R1 is speaking RIP version 1 to router R2. Let's make sure we can still ping our backbone routers as a quick test. Ping 3.3.3.3. Great. Ping 4.4.4.4. We have success there as well. There's only one requirement that we have, and that requirement is we said that the backbone routers needed authentication. In order to have a backbone router as your neighbor, you need to authenticate with that router. Let's see how that's done. No need to do any configuration on router R2. It's all going to be done from router R1 and the backbone routers. So let's go over to router R1 and let's create what is called a key chain. We can have more than one key chain, but we just need one key chain on router R1. We say key chain, and I'm just going to name it simply keychain 1. Notice I am using all uppercase lettering. I think that's a good approach to use. That way when I go back and look at my configuration, I'm going to be able to quickly notice that, oh, that's something that I typed in. That's not some sort of an iOS keyword. We're now in keychain configuration mode, and I'm going to specify a key. And we could have more than one key on a chain, and they could be valid during different times of the day, but we're going to keep it simple. Let's say key 1 takes us into keychain key configuration mode, where we're now going to say key hyphen string, and let's use a string of Cisco in uppercase. We've now defined our key. Let's now go into interface serial 0/0.1, and let's say that number 1, we want to do RIP authentication. Let's say IP RIP authentication mode, and our options are text or MD5. We're going to select MD5, and we're going to specify the keychain that we're going to be using. We're going to say IP RIP authentication key hyphen chain keychain 1. We need to do the same thing for our other subnet, or rather the other sub-interface. We go into interface serial 0/0.2, and we reissue the command IP RIP authentication mode MD5, followed by IP RIP authentication key hyphen chain, and we're going to use the same keychain. It's keychain 1, and we're done with our configuration on router R1. In fact, let's go ahead and save this configuration. We do a copy run star as we talked about last time. Let's go over to router BB1, and on router BB1, let's go out to global configuration mode and set up our keychain. Now we're going to have a couple of keychains here. One keychain is going to be used for authenticating with router R1, and the other keychain is going to be used for authenticating with the other backbone router. So we say keychain, and we'll call it keychain 1. By the way, that did not exactly have to match what I had configured as my keychain name on router R1. The key string has to match, but the keychain name does not have to match. But to keep it simple and easy to understand, I use the same keychain name. Let's create a key on this keychain. Let's create key 1, and let's say its key string is Cisco. Let's create another keychain now. Let's say that we want to create keychain 2 this time. We'll create another key 1 on this keychain, and let's call this, just to keep it simple, let's also give it a key string of Cisco. Now we need to go in to our interfaces, our sub-interfaces, and specify what keychain they're going to use for authentication. Let's first go into interface serial 0/0.1. You'll notice on screen that that interface is pointing over to the other backbone router. Let's use keychain 1 for that. Or actually, let's use keychain 2 for that. Let's say IP RIP authentication mode MD5, followed by IP RIP authentication key-chain keychain 2. Let's go into our other serial interface, or rather serial subinterface, interface serial 0/0.2 this time, and we're going to say IP RIP authentication mode MD5, IP RIP authentication keychain, and this time it's going to be keychain 1, pointing back to router R1. We're now done with our configuration on router BB1. We could either say copy run star, or here's another shortcut I'll offer to you. It's an older way of copying our running configuration of the startup configuration. It's an abbreviation for the write command. We're saying we want to write memory. We can just give a WR for short, and that's another way to copy the running config to the startup config. Well, let's finish things up over on router BB2. On router BB2, we also need to create our keychains. Let's say keychain 1, and we'll give it a key 1 with a key string, keeping it consistent with Cisco. We're going to create our second keychain, keychain 2. We'll give it a key of 1, and its key string is also Cisco. The last two things we need to do, we need to enable RIP authentication for our two sub-interfaces. We go into interface serial 0/0.1, noticing that that is the sub-interface that points over the backbone to the other backbone router BB1. So let's say IP RIP authentication mode MD5, IP RIP authentication key-chain keychain 2 in this case. Then we go into interface serial 0/0.2, which is pointing back to router R1, you'll notice. And we say IP RIP authentication mode MD5, IP RIP authentication key-chain keychain 1. And we're done with our configuration on router BB2. Let's do another copy run star. And I think we've completed our configuration. Let's go back over to router R2. Let's go to router R2, do a show IP route. Make sure that we seem to have full reachability. Let's do a quick test. Let's go around our different loopback interfaces. Ping 1.1.1.1, successful. Ping 2.2.2.2, no problem. Ping 3.3.3.3, ping 4.4.4.4. So we're pinging from one area of the network into another area of the network. And think about what we're doing here. We're coming from a RIP version 1 speaking router into a RIP version 2 speaking router, and we're going out to a backbone that is authenticating with router R1, and these backbone routers are authenticating between themselves. I don't think we've yet saved our configuration for router R2, so let's do that now. Let's do a copy run star, and this is going to conclude the configuration portion of lab number 2, configuring and verifying RIP version 1 and RIP version 2. In this lab number 2, we took a look at how to configure and verify a couple of different flavors of the Routing Information Protocol, or RIP. We saw that RIP version 1 had some limitations, and we saw how we could overcome some of those limitations with RIP version 2. Specifically, RIP version 2 was a classless routing protocol, while RIP version 1 was a classful routing protocol. That gave us some routing issues. We had to overcome that using RIP version 2 in part of the network, and by using a static route on one of our routers. We also illustrated how RIP version 2 supported authentication between routers. Coming up in our next lab, lab number 3, we're going to take a look at what's usually considered to be a much more advanced routing protocol, Cisco's EIGRP routing protocol, the Enhanced Interior Gateway Routing Protocol.